from chapter 26, Current and Resistance, taken from the book Principles of Physics, 10th edition. When 230 volt is applied across a wire that is 14.1 meter long and has 0.3 millimeter radius. So here we have a wire and the length of the wire is 14.1 meter and the radius of the wire is 0.3 millimeter. So now what I'm going to do, I'm going to draw the figure based on the information. So we have a wire. So this is our wire and this wire length is 14.1 meter. Clear? So we have a wire and in this wire we are just giving the potential difference. That means voltage across the wire. How much voltage we are going to apply? 230 volt. Clear? So the voltage applied across the wire is 230 volt. And what is the length of the wire? The length of the wire is 14.1 meter, right? So the length is 14.1 meter long. And the radius of the wire is, this is our radius, right? And the radius of the wire is 0.3 millimeter. The magnitude of the current density is 1.98 multiplied by 10 power 8 ampere per meter square. That means the current over area is the current density, right? So that means let's we take a cross-sectional area. So the current density J value, which is equal to 1.98 multiplied by 10 power 8 ampere per meter square. By using all these values, we are going to find the resistivity of a wire. They did not mention the material of the wire. They just give the length and the radius and the current density and the voltage applied across the wire. By using all these, we are going to find the resistivity. What is the resistivity? The rho value of the wire we are going to find. Clear? So now, for finding the value of the resistivity, we have to recall the formula. What is the formula for the resistance? The formula for the resistance R, which is equal to resistivity rho multiplied by L over area. Clear? So this is the rule for finding the resistance. Clear? And from this formula, we are going to rearrange this equation in terms of resistivity. So if you rearrange this equation in terms of resistivity, how you can write? You can modify it as rho, which is equal to R multiplied by area over L. Clear? So now better I'm going to write what is given in the question. The length of the wire they mention 14.1 meter and the radius is 0.3 millimeter. So we have to convert it to meter. So I have to multiply by 10 power minus 3. And also they gave the value of the current density J, which is 1.98 multiplied by 10 power 8 ampere per meter square. And the voltage applied across the wire is 230 volt. Now you have to see this. The length we already have. Area we can find by using the radius value, because the cross-sectional view of the wire is the area of the circle, right? If you see the cross-sectional view of the wire, it is exactly seems like area of the circle. So the area of the circle formula is pi r square, right? So we can use that formula for finding the area. Clear? And resistance, we can find the resistance by using the current and the voltage, right? So better we can just use one by one. So what I'm going to do, first I'm going to find the current, because if you want to find the resistance, you need the current, right? So better we can start. So that means this is the main formula we are going to use for getting the answer of the resistivity. So for this, what are the things we are going to use? We are going to use the formula for the current. Current, we have two formulas, which is V, which is equal to I multiplied by R, and also we have the rule for the current density, right? The current density J, which is equal to current over area, right? So better we can use this because the current density value is given in the question. So better I'm going to use this equation for finding the current. So we know that the current density J, which is equal to the current over area, and from this what I'm going to do, I'm going to rearrange this equation in terms of current. Therefore current, which is equal to current density multiplied by area, and here this area is nothing but the cross sectional of the wire is nothing but the area of the circle, which is pi r square, right? So now what we are going to do, I'm going to substitute the value here, and we can just find one by one, and later on we are going to substitute all the values in the resistivity rule. Clear? Okay. Okay, now we are going to find the value of the current. What is the value of the current? J, 1.98 multiplied by 10 power plus 8, am I right? Plus 8 ampere over meter square multiplied by pi multiplied by 0.3 multiplied by 10 power minus 3 the whole square. Why I just multiply 10 power minus 3? Because it is in millimeter, so we have to convert that millimeter to meter. Okay, now I'm going to identify the value of the current. So 1.98 multiplied by 10 power 8 multiplied by pi multiplied by area, sorry, resistance, sorry, radius, right? 0.3 multiplied by 10 power minus 3 the whole square, which is 55.98. What's the value of the current? 55.98 multiplied by, sorry, what's the unit? The unit for the current is ampere. Clear? Okay, so I'm going to keep this current here, and now what we need the resistance, right? So how we can find, because we have the resistance rule here, therefore rho, which is equal to R multiplied by A over L, correct? So now if you want to find the resistance, I have to use the Ohm's law, V which is equal to IR, therefore R which is equal to V over I, right? So now V value is already given, am I right? So I can use the value of 230 over the current value I can use on the first part, which is 55.98, right? So what's the value of the resistance? The value of the resistance is 230 over 55.98, which is 4.11 ohm. Clear? So we already got the value of the resistance, but the only thing we have to identify the area. Area, as I mentioned, the area is nothing but pi r square. So pi multiplied by 0.3 multiplied by 10 power minus 3 the whole square. So let's we find the value of the area, pi multiplied by r, which is 0.3 10 power minus 3 the whole square. So actually the area value is 2.83 multiplied by 10 power minus 7. What's the unit for the area? Just meter square, correct? Now we can easily find the resistivity of the wire, right? Okay, so now what I'm going to do, I'm going to write the equation again for the resistivity. Rho multiplied by rho, which is equal to R multiplied by A over L. R value I'm going to substitute here, A value I'm going to substitute here, and L value, which is already given in the question as 14.1 meter. So I'm going to substitute. Once you substitute all these, you will get the resistivity of the wire, right? So R value 4.11 multiplied by 2.83 multiplied by 10 power minus 7 over 14.1. So the resistivity value I have to calculate now, 4.11 multiplied by 2.83, 10 power minus 7 over 14.1. So I got the answer as 8.25. 8.25 multiplied by 10 power minus 8. And what is the unit for the resistivity? Which is ohm meter. You can apply the rule, or the unit for each parameter. The unit for the resistance is ohm, right? The unit for the resistance is ohm, and the area unit is meter square, and the length unit is meter. So meter get cancelled with this. So finally you'll get ohm meter. So this is the answer for the first question. Clear? Clear? But while you calculate the resistivity, please find the value of the resistance and area carefully, because if you made a mistake in calculating the resistance and area, then the resistivity value will be wrong. Clear? Okay.